going to talk about Panasas. On the slide you see frustration-free data storage for scientific HPC workloads. So what does Panasas do? We are building an appliance. That's why it says frustration-free. We have done that from the start. So we're bundling the hardware and the software or file system. It's data storage. As I said, it's a file system. It's a POSIX compliant file system. And it's designed for scientific HPC workloads. That means it's scalable. It gives you the bandwidth you need. Customers do a lot of things with our file system. We have CFD simulations in both race cars, airplanes, climate, weather forecast, bioinformatics. We have all of those. We have done a survey to look at what people need when they buy storage. What are the key decision factors? And the thing we learned from that was that, of course, we're talking about HPC storage, that highest performance is one of the keys. The storage needs to be fast, but it also needs to be fast when the circumstances change, when the complexity changes. People want frustration-free storage. You want it to have it set it up, and then you want to forget it. You don't have to fiddle with it, all of that. You just forget that the storage is there. It needs to work. It needs to be flexible. The days when we only had one application is gone. Applications change all the time. The I/O loads change all the time. It's not just about high bandwidth, large files. You need to manage small files, all kind of different I/O patterns. Of course, when you thinking about purchasing of a file system, it needs to be cost effective. Not only the acquisition cost, but also the total cost of ownership. What does it cost to maintain the storage? End users want your storage to be reliable. The storage needs to be up and running all the time. The system needs to heal itself. If there is a failure, the system needs to reconstruct the data without that the end user has a bad experience about that. Customers also like the support. You need to have an organization which gives you an excellent support in case that some things goes wrong. All of the customers I know of Panasas, they really love the support of Panasas. So what are the key things of the Panasas parallel architecture? In the drawing you see the client systems on top, and then below we have what we call the data storage nodes and the metadata or director nodes. Like in a true parallel file system, you need to separate metadata and data. Metadata is handled by the metadata nodes, and once a Linux node, most of the clients are Linux nodes, has contacted the metadirector node, that Linux client will get a map, a layout of the file. And with that information, the client can then contact all of these storage nodes in parallel to retrieve the file. The system needs to be linear scalable. That means you need to be able to add storage nodes, and your performance needs to be scaling linearly. We have customers with over 1,000 storage nodes on Panasas. The Panasas system is also easy to scale. You can add storage nodes on the fly. The system will automatically integrate those, and the system will in the background migrate data from the existing nodes, which will be full or fuller, to the new nodes, which will be empty. All of that in the background automatically. A Panasas file system, the more storage nodes you have, the more reliable your system gets. And this is something like completely counterintuitive. Normally when you have a RAID controller, you have a certain probability that something goes wrong. If you have 1,000 RAID controllers, that probability will go up. In Panasas, it's reversed. The higher the node count, the more reliable the system gets. Panasas has an excellent mixed workload performance. That means we are not just good in handling large files in bandwidth, but also in small files. To do that, we are putting the small files automatically on the SSDs. The Panasas system will automatically load balance data between the storage nodes. That way, we will remove hotspots. It's a appliance. It's a hardware combined with software. Panasas is not a software-defined file system which you can load up on your Linux compute nodes. No, it's a complete appliance, the hardware combined with the software. We remove the noisy neighbor problems with that. We don't store data on your Linux nodes. And as I said, Panasas systems just work. You don't want frustrated application users. So how has our product evolved over time? Our classic product was based on our proprietary hardware, and we have moved off that proprietary hardware to COTS hardware. The first step was removing the director nodes, the director blades, to a director node using a commodity hardware. And then the next step with our Ultra platform is to remove our proprietary storage blade also with the COTS hardware. Today it's Supermicro and Intel boxes we use, but we're also looking at other hardware vendors to use their boxes. We don't care anymore what box we use. But Panasas still delivers this as an appliance. So we deliver you the hardware combined with the software. For the Ultra box is the last hardware we are shipping. We have a 3-tier storage domains in there. Depending on what kind of data you want to store. We have large files will go onto the hard drives. Small files will go onto the SSDs. And the metadata, those will be stored on an NVMe SSD in the box. That way we really use the devices where we're best suited for. For large files, you want just streaming bandwidth, where we think hard drives is the best. Small files, you want random access, SSDs is best. And metadata, there you want the lowest latency, there you want an NVMe storage system. In the Ultra node, we have changed the underlying low-level file system, the OSD file system, V2 to a new version V4, and it's now running completely on Linux. That way, the old version was running on a BSD, which made it difficult for us to faster incorporate new kind of technologies. For example, it's more difficult to find the drivers for InfiniBand or NVMe on BSD than on Linux. Now that we've completely moved to Linux for the OSD, we can better integrate new technologies. Today is 25 gigabit Ethernet. We're almost having the InfiniBand option ready. I don't think we will go for Omnipath, as that seems to have been stopped developed. But as it's Linux, it's very easy for us to add more interfaces or interconnects. At the same time that we have moved this underlying stack from BSD to Linux, the high-level API we're using is still fully compatible. So you can have a PanFS file system with the old and the new hardware in one namespace, for example. This is how the hardware looks, which we are using today. As you see, it's just COTS hardware. It's the 4U building block, which delivers about 4 gigabytes per second. It's up to 300 terabytes in 4U today. It's flexible. As I said, it's meant for multiple workload types, as I explained, for the small files on the SSD and so. And it's very easy, very simple to manage. It's a very low administrative overhead. It's a single point of support for the complete system. When there is an issue, you call Panasas, and you have direct somebody who knows Panasas, who can help you solve your problems. So this is what we have today. The things we are looking for the near future is, we have a great high-performance parallel file system for HPC workloads. We have high bandwidth, it's easy to use. It's POSIX compliant. It's fully cache coherent. The one thing we are now lacking for some workloads is the ultra low latency. We have seen that AI workloads, they really want a very low latency to the data, and they want to have like a single big image of a file. It's difficult. You can do some caching, and you can load ports of the file into your local machine and do some caching. But what we don't see is like a single global namespace which gives you those ultra latency. And that's why we are now developing our PanFS Ludicrous mode for extreme acceleration. And what we are going to do there is we're going to use COTS NVMe boxes, NVMe over Fabric box. And that way, your Linux nodes will be able, and it's just COTS hardware, just COTS NIC interfaces, a COTS NVMe box. And because we have our PanFS client, which resides on the Linux, your Linux server, we will integrate our PanFS file system, and portion of that file system will be able to access over the NVMe over Fabrics, giving you very ultra low latencies. At the same time, we will guarantee the fully cache coherence, and so the Panasas system will do the heavy lifting of moving the data from the classic hard drives and SSDs to the NVMe box. You can even have a mixed environment where you have a cluster without access to the NVMe fabric, which just has access to the same files. Or you can have a part of your cluster with your special AI devices, which will have access to those NVMe box. So you don't have to partition a file system for AI. You don't have to have a different cluster. No, this can be under one hood, one global coherent parallel file system for you. We expect this, development is ongoing for this. We expect this to be available end of next year. I'm really excited for this ultra low latency method. So to summarize, what we have is we have fast 4 gigabyte per second building blocks, which you can just scale. As I said, we have a customer with 1,000 storage nodes today. It's frustration-free. It's a simple administrations. We have large deployments where we only have like one full-time equivalent to administer the storage. And I'm talking about a multi-petabyte HPC storage. Reliable, always available. We have a RAID 6 plus mechanism. That means that the large files will be protected by RAID 6. Small files will be triplicated, and we will extra protect your directory information. So even in the unlikely event you have too many failures on your big file system, your directory structure will still be intact. You will be able to move to all the directories. Some of the files will be impacted by those too many losses. You will get a list of the files which were impacted, so you can restore them from backup. But the key is your file system will still be online. With traditional multi-petabyte file systems, if you are so unlucky to have too many failures, you will lose your complete file system. And cost effective. While we might not be the cheapest at the purchase price, if you look at the total cost of ownership, we are really cost effective. That was all I wanted to tell you in those little 15 minutes. Questions, please.
Any questions for Sven? No? Okay, thank you.